from standard form to scientific form. So you should be cutting those out when you're finished. Just leave your paper in the corner of the desk. We'll dispose of it later. Yes, all of them. And you can just cut that in half so Jack can keep them. Then everyone should get a marker board. One of the marker boards. I'll cut it. And marker. Okay, so I'm bringing a marker around for you for your marker board. Check your marker and make sure that it works. And please don't hit these boards up against your desk loudly. Be gentle with them. There shouldn't really be any talking right now. Okay, so you should have your little cards cut out. All right, so I need your full attention now. No more talking. Everybody have what they need. Okay, the first thing that I want you to do, some of you are still finishing cutting those out, but y'all can stop right now and you can cut them out in just a minute. Because I'm going to ask you to answer some questions. So, we have 3 different numbers written in scientific notation on the board right now. And I need you to tell me which number these 3 expressions represent. These 3 expressions all represent the same number. Write the number on your whiteboard now. These 3 expressions all represent the same number. Write the number on your whiteboard now. And you can write down the original problem in scientific notation and then convert it. So, these 3 numbers are all in scientific notation. They all represent the same number when they're converted into standard form. Show me your boards now. Okay, I have a lot of different answers. So I'm going to ask Tyler, how did you get 3?
I just looked at all of the numbers.
Okay, what is that number called in scientific notation? The coefficient, right? So does that mean that that is necessarily my number converted into standard form though?
No.
No, it doesn't. So Jordan, you have 3,000. How did you get 3,000? On every bit of them you move the decimal. You are correct, okay? So let's review quickly. We have 3,000. Where is my decimal and a whole number?
At the very right.
At the far right. And then this is times 10 to the negative 1. If I have an exponent raised to the negative 1, Aiden, do I move that decimal to the left or the right? The left 1, because that tells me 1. So my new number now is 3,000. What about 3 times 10 to the third? Again, you told me that my decimal is on the far right when I have a whole number. I have 3, so Alicia, where am I going to move my decimal? How many times? 3. So I get 3,000. Do y'all see the pattern?
Yeah.
Now I have 0.3 and a positive 4. So I move that decimal to the right 4 times and I end up with 3,000. So all of these written in scientific notation actually still give me the same number of 3,000. And you should not be writing on your board unless I ask you to. Okay, which expression, you chose all 3 to convert, right? Okay, did anybody choose a specific one to convert to get 3,000? Which one did you choose, Amy? middle one, okay? Was the 3 just more appealing because it didn't have a decimal and you knew, okay. Anybody else choose a different number? Mitch? Oh, good. We're going to the next one anyway. Right. So, let's see here. Right now, I want you to tell me which one of these numbers is greater on your board. You will have to convert them from standard or from scientific to standard in order to determine which one's greater. Whether you do it mentally or you write it out on your board, it doesn't matter. But write down which one is greater. Okay, a couple more minutes or seconds and then we'll. Okay, show me your whiteboard. Okay, I think it's kind of unanimous. Overall, everybody said 4 times 10 to the negative 1 power. What does that convert to in standard form? What? 0.4. And what does this convert to? 0.008, right? So that one's a lot smaller than 0.4. So good job on that one. Now we're going to move on. So with your card set A, okay, you are going to take turns to match a card in decimal notation with the card in scientific notation. So y'all can establish the difference between scientific and standard, right? So if you have, let's see. This will be an example. I'm going to come around with it so you can see. This is scientific standard, right? Scientific standard. Scientific standard. Scientific standard. We know that, right? Scientific and standard. So what you're going to do with these 2 card sets is take turns matching the card in scientific notation with the one that matches in decimal notation. So basically, instead of converting it on your paper, you're just going to match them together. They've already been converted for you. Each time you match a pair of cards, we're going to do like we did last time with our 5 lesson. You're going to verbally justify why to your partner you're matching these 2 together, and they're either going to disagree or agree. Then your partner's going to go, and they're going to either or you're going to either agree or disagree. So each time you match a pair of cards, explain your thinking clearly and carefully. Place your cards side by side on your desk, not on top of one another, so that everybody can see them. You should agree with the explanation or challenge it if you think it's wrong. Don't be scared if your partner has matched something that's bogus and you don't agree with it to be like, oh, I think you're wrong. And tell them why, but let's be respectful, okay? It's important that everyone in the group understands the matching of each card. So do not match a card and just lay it down and assume that your partner knows why. And lastly, you should find the 2 cards that do not have a match and write the alternative notation for these measurements on the blank cards. So you have 2 blank cards that you cut out. Some of you might have thrown them away. If you did, it's not the end of the world. We can get you some more. But on those 2 cards, you're going to have a number in scientific notation that does not have a match and a card in decimal or in standard notation that does not have a match. You're going to actually convert that and write it on those cards and match them together. Does that make sense? Okay, right now with your partner in an inside voice, I want you to start doing that. You're just doing the little parts in scientific and decimal notation.
So these two match up because you have 2 times 10 to the power of 1. So you would take the decimal and go to the right ones, and that would equal 20.
And you can use your whiteboard if you need to convert these by hand first and then find the match. That's okay. I'm so proud of your math terminology.
These two, because when you move it 4 times to the negative. So these two you have to convert. So that's really cool. You're just gonna go to the
That's
first.
one plus left is negative equal.
And this one is gonna be 1, 2, 3. Times
You have to
2
put these
to
spaces up the foot. So, you'll be over here with this.
On the ones that don't have.
So does that mean you're gonna move your decimal at all? Yeah. So this would just be. So is that gonna be a -2 or a
No, it's your ability. Yeah. You
Laying
just
on
woke
the
up.
iPhone.
Okay, so if you have a -2,
I was paying on the iPhone.
Get it? I forgot to turn it off.
No, I saw it on
keep in
No, I
mind, guys,
didn't. I
don't
didn't
freak
turn it off.
out. 2 of these do
Yeah,
not
yeah.
have a match. So look at yours carefully.
This is the 7.
Is it gonna be 12?
It's not that big.
What's it gonna be?
They say that we're gonna make 7 heads. Just make it straight to the 8.
Okay, some of you are finished. Raise your hand if you're completely finished. Okay, couple more minutes. I want you to double check your answers. Yes?
Are they already together?
4 go down to 8 times.
Chess.
So those of you that are finished, I want you to, let's see, raise your hand if you're finished. Okay, I want you to look at theirs, and I want you to pair and share your responses. I want you all to look at theirs and pair and share your responses. You got 'em right. You have to move your card. Okay, you two, I want you to pair and share with them, just to look and see if your cards are matching the same, okay?
He's gonna come over.
Come on. Yellow.
Not even one. Here we are.
Oh, okay.
You're gonna make cards for
So,
that.
you can just go.
We already we did that shit.
Yeah,
Look at
and
what's
that card, you
saying.
can check it out.
How's that -3 on the screen? This one. Because
Okay.
1 point,
This is
1
actually-
point.
Oh, it's -2,
1,
yeah.
2, -2.
Because if 2 times 10 to the 0 power, the decimal's not moving at all. So you have to, so go back and recheck your answers and compare and share and see if there's something different. You're supposed to
I
compare and share.
agree with Rose. I agree.
2 times 10 to the 0, you're not moving your decimal at all. Okay, go back to your seats, pair and share time is over. Some of you still have a couple left to match, that's okay, it's just a couple groups. So what we're gonna do is going ahead, I'm gonna give you instructions for the next session. And then I'll come around and eliminate some of your pairs if you're not finished. So, we've taken turns, you've justified, you've paired and shared. You know that your pairs are correct based on not only your justification, but justification from other partners. So what we're gonna do now is match the objects from card set B, which are the pictures with the corresponding measurements of card set A. So we're gonna apply these measurements to real life knowledge. Okay, you may wanna put these objects in size order to help you first. So an inchworm is definitely gonna be smaller than like an airplane, right? So you're gonna put them in order smallest to largest. Not right now, just a second. Number two, it's important that everyone in the group agrees with the match. Again, as you match an object with a measurement, these are all measurements in meters. That's what our little M stands for, right? So think of it in terms of a meter. It's almost the size of a yardstick, okay? When you finish matching the cards, check your work against your neighboring group. So we're gonna pair and share again once you've matched your objects. If there are differences between your matching, I want you to ask for an explanation, and if you still don't agree, explain your thinking. You must not move the cards for another group. Instead, you're gonna explain. So when you pair and share here in a few minutes, you're not gonna say, oh, that doesn't go there, and move the card. You're gonna say, I disagree with that because, show them what you did, talk about it, and see if you can come to a conclusion as to why it's incorrect or correct. Does that make sense? Any questions? Okay, y'all can go on ahead and go. Remember, it might help to put them in order, largest to smallest first.
Nora, have a that lower day. Regular dance. So we've got it done. It'll go the distance from Earth to the moon, the height of the mountain, and the wingspan of it. What's the tree? Height of the way is depends what tree it is.
Think about it. There's not going to be anything close to that, so think about it in terms of that.
Second biggest.
What do we do after we're done, like, going to erase these?
Then you match them with their scientific notation measurements.
But we know that the
That is for our next step. So you can go ahead and write. The paper that I've just handed to you is for our last set. You can go ahead and start cutting it out once you've matched your objects, your real life objects with your measurements. Okay, so for instance, this 2 times
Wait.
So one on Earth is about 60 meters tall, and one on Earth is about 3 meters. So you're matching a real life object with the measurement. Do you think that a cellular is 2 meters? Or 20 meters? About a yard. 3 feet. So you think 3 feet times 20? Probably not, right?
What is it?
3 meters, you think it's
3
9 feet?
0.0001.
No, what about these smaller ones? Could it be one of those?
Big.
I think that's super tiny. Question? How are your snaps looks like?
So do you have the thickness?
Thickness of it all, you're good.
Yeah.
0.2 with the length of the fly.
Cool. 2 meters height of a 3 meters length of a track, 20 meters height of a tree, 60 meters wingspan of an aircraft, 8,000 height of a mountain. You've got them all.
Whoa.
Good job.
That was crazy.
Thickness of a dollar bill.
That was like.
Y'all are rocking this. Y'all are doing such a good job.
Yes, you were.
You got it? Good job. Okay, parent share now. I've come around and told some of you that you've gotten ones right or wrong. I want you to parent share and to see if you find any differences in your partner's responses. And then go on ahead and cut out your comparison sheets. What do you have left? It looks like you didn't convert this one.
So you want to cut these out?
Me and
Don't ask how I know.
Yes.
Where? Where did
So it's 12.
I really like how some of you put them in order before you paired them together. I think that really helped.
Tyler. Oh, Tyler. Talking everything.
Totally stay focused.
No, I didn't put that.
I'm like double
Okay, so let's talk for just a second. I want to come to the whole group and talk about something. The main mistake or misconception that I'm finding, all ears, all eyes, is the 0.012 and then the 0.0001. Okay, a lot of y'all are getting those mixed up with your real life objects. What does the dollar bill say at the top?
thickness.
Thickness of a dollar bill. So it's not the length of a dollar bill, it's the thickness of a dollar bill. So pay close attention to that. Which one is greater? The length of a fly or the thickness of a dollar bill?
The length of the fly.
The length of the fly, okay? Which one's greater, 0.012 or 0.0001?
0.012.
Yes, okay, so pay attention to those comparisons. Read what the picture is actually stating you're comparing. And again, most of you are finished, so as you continue to cut out your comparisons, let me get my projector back up. So, since most of you are finished, I don't always do this, but since most of you are, you've been given a set of arrows. And what you're going to do is make comparisons between the objects that you've been given, stating how they could compare. So since we haven't done this before, I'm going to give you an example on the board. So you should have something like length of a truck, okay, which is 3 times 10 to the 0 power, which equals 3 meters. And then you also have the wingspan of an aircraft, and that's 6 times 10 to the 1 power, which is 60 meters, okay? So your little arrow comparison that you would, or could put here, would be times 20, right? If I multiply 3 meters times 20, it gives me my 60 meters. So you're making comparisons between the real life objects based on the scientific notation and standard form that you've matched together. Does that make sense? These are challenged. Okay, there are lots of comparisons you can make. Your comparison might be different than your neighbor's, so discuss them. It's okay if you parents share the majority of this activity. So go ahead, cut out your arrows, and start to make your comparisons. As you make them, place them on your poster. This is how they're going to be matched and placed on your poster. You can be creative with how you match them.
Oh, I get that now.
What's,
Raise your hand if you have questions. I can come to you.
720 times 400 is 800.
Good. Your poster does not have to look just like your buddies. So there are lots of different comparisons.
I don't know if you use that for neighbors because the zeros are all different.
As you do this, I'm going to come around and pick up your marker boards. Where's yours? Well, it's just process of elimination, so you can just look. So you got that one, now look at this, what would you multiply this by to get this, or this by to get this? You're gonna have to have similar numbers at least, right? So look at that, it's just process of elimination. And these are challenged, they're not supposed to be easy, so. Marker boards.
That's 9. That's 9.
why is there so many?
Because there are lots of different comparisons you can make, they're not all gonna be the same. So you're not gonna use all those, and you can make 2 of them for your own. Will you hand me one of those? Notice, guys, that you have a couple of blank arrows, okay? If you decide that you wanna make your own comparison that an arrow is not there that applies to, then you can make your own arrow. So let's say that I didn't have times 20 right here. This wasn't an option in my card set, but I wanted to compare the length of the truck to the wingspan of the aircraft, then you can make your own and just write times 20 on it. So you can do that as well. You have 2 of these. Yes. Good. Yeah. That's what you're supposed to be doing. Oh, yes.
When we do things, can we do like arrows like this?
Sure. Okay, that's cool. Make it like a maze.
Okay, take it off. Oh, wait. But don't tell me about it. Here we go, wait.
Okay, you have a couple more minutes to finish up with this, and then we are gonna do a little post test to see how you gain your knowledge.
A what?
A post test. It's just a quiz. It's not gonna be huge. It's fun. It's gonna help me see what you learned. It's just like this, comparisons and stuff. So y'all be fine. Y'all done great with this.
Fudge.